in a minute. Okay, we have someone here to talk about the peer mentoring program again.
Hi, my name is Cody Craig. I'm one of the peer mentors for the School of Computing. I just wanted to let you guys know that we're having a social on Thursday the 25th from 12 to 1. It's in Warnock in the Capitol Gallery. Even if you're not in the mentoring program, you can go get more information about it and also just meet other students. Have you guys done pair programming yet? No? Yes.
What kind?
Pair programming.
No.
Okay. In your future classes, you'll be working with partners. It's a great way to meet people so you don't have to go into those blind. Also a great way to meet your professors for future classes, and then just meet with people in the program. So if you want to, you can email your professor and he can pass your email on to Tracy, who's our program coordinator, and she can get you added if you want to become part of the mentoring program as well. That's all I've got.
Okay, well, welcome back from fall break. Hope you're all ready for the second half of the semester. We'll wrap up the first half, of course, with the midterm, and I'll have plenty more to say about that shortly. Our goal is to have the midterm graded Thursday, and also to have PS6 graded by Thursday. And if we meet that goal, then on Friday you'll see your exact average in the class through PS6 and the midterm. And I mention that because the last day to withdraw from classes, if you're considering that, is Friday. So you won't have long to make a decision, but at least you can see where you stand. If you're worried about that, if you think your average is low and you want to talk to me, please come and talk to me, and I'll be happy to give you my judgment. This morning I released the work for next week, so the Zybook activities in PS7 as well are out. Not due this week, they're all due next week. And we'll get back on our usual schedule. Any questions or problems about anything before we go any further? Okay. Might as well. For those of you watching the video, we're having trouble getting the screen capture, so we're just going to video the screen, except that's not even working right now. So let me get that to work. Okay. So the midterm is on Wednesday, 2 days from today. I expect almost all of you, you're in the section 1, will come to this one, 3 o'clock to 4:20 right here, where we usually meet. If you have last names beginning with A through K. Otherwise, you should go upstairs, right up above us. No, got it backwards. Yeah. A through K goes upstairs. Yeah, got to do this or it'll be the wrong number of people. So A through K goes upstairs. Everybody else comes down here. Okay? Yeah. Those of you that are in the hybrid class at 5 o'clock should come here. Okay? So that's the logistics of the thing. Be sure to bring your university ID card, because we'll check it when you hand in your test. You can bring one 8.5 by 11-inch sheet of notes. You can fill it in front and back. You can handwrite it or print it out, whatever you want to do. you're going to need to turn it in after the test. So you'll get 2 sheets for the final. So if you want to use that 1 sheet for the final, be sure to make a copy before we confiscate it. And there will be a supplemental midterm review. What it'll be about is answering any questions that you have, and also going over yet a second sample midterm. So that's Tuesday at 5:15 in here. And we will do our best to stream that. Okay, now, this will be a pretty dull review unless you have questions. And if you don't have questions, I might as well stop now, but I'll go on even if you don't. But what you're going to see are lists of things we covered the first 6 weeks of the semester on PS6. People always ask me, they want a study guide. And I guess these slides are your study guide. But it's not like this is a class where you've got to memorize some stuff and regurgitate on the test. The idea is you've learned this material well enough that you can apply it to new situations. So you can write a loop, for example, that you've never written before, using the concepts that you've learned, of course. But before we get into that, I often show this slide here on the first day of class, but I decided this year to wait for a while. To try to put in context what you've been learning, where it fits into the larger realm of computers and programming languages. So a programming language, we said the first day of class, is a formal notation for describing computations. Programming languages have been around since the mid-50s, so a long time, over 60 years. And they were first invented because people had a hard time. It was difficult to program computers without a high-level human-centered programming language. Back then, all you had was machine language or assembly language, which is barely more than a machine language. Now, you tell me, it's a notation for describing computations, but to whom are we describing computations? And you write a program. Yeah?
It needs to be executable by the computer, but it's also supposed to be able to be easily read by any other programmer. Okay.
So we said it needs to be executable by the computer, but also it needs to be readable and understandable by other programmers. And that's exactly right. When we write programs, we've got 2 audiences. We've got people, and we've got the computer. And both are important. And that's part of what makes programming difficult, is you've got to deal with both audiences. So if that's what a programming language is, then a program, stuff you've been doing, is a description of a computation written in a programming language, in particular Java in this class. Now, you may wonder, okay, you've been studying Java here for 6 weeks or more, and you may be wondering, well, my friend knows how to program in Python, or this class is taught in C#, or this class uses C++, and it would be very natural if you're wondering how they all relate. Well, the answer is that the syntax, the way you write a loop, the keywords that you use, the appearance of a program, differs from language to language. And it differs a lot between certain languages. So a Python program looks quite a bit different than a Java program. On the other hand, a Java program and a C# program look pretty much alike. So they are, languages vary a great deal, but the concepts, the thinking that you do when you're programming is the same. So the thought process you go through when you write a loop in Python is the same as the thought process you go through when you write one in Java. And the same goes with methods and classes or whatever. It's all easily transferable. And after you've had classes and learned a couple of programming languages, after that point, we don't bother with teaching you programming languages anymore. We figure that you have enough experience that you can learn future languages on your own. And if you continue in the field, that'll be absolutely essential, because none of the languages that we're using today at the U existed in any form when I was a student, I guess with the exception of C. So That'll be true for you as well. Change is only accelerating, and new languages and new approaches are being created all the time. Now, you may have heard me talk about a compiler, and back in the day, it was obvious what a compiler was, because you would write your program in a text editor. Think about sort of like Notepad, really. And you would save it to a file, and then you would go to the command line and compile it. So you knew when you were compiling the program. And when you compiled the program, error messages would appear. And when error messages appeared, you would go back into the editor and fix them. The errors weren't flagged inside of the editor. They were written out to the command line. And so the way it felt the program was a lot different than it is for you. My wife was a software engineer, and she says that she used to learn about programming languages by reading the manuals while the programs were compiling. So there are two things that don't exist anymore, for students at least. There are no manuals anymore, at least no physical manuals. Everything's online. And second of all, there's no time when you think, oh, the compiler is running. But in the old days, even a small program, it took a while for the compiler to run. So where is the compiler in Eclipse? When does the compiler run? What does the compiler do? Yeah?
Is it when you hit the run button?
Well, he said, is it when you hit the run button? And that's reasonable. It's sort of, but that's not the exact answer, yeah?
Isn't it always running to catch errors?
It's essentially always running. That's the truth. Because as you write the program, it's flagging errors, right? You make a mistake before you saved it, before you go to the next line. Sometimes it's flagged in a line, it's underlined it in red, and you fix it. So what the compiler does is it translates your Java program from Java into some other language. Or more in general, a compiler translates a program written in one language to a program written in another language. And along the way, it finds errors in the program and spits them out. Now, if you try to run a program without having fixed all the compiler errors, it won't run. And you have to fix the errors. But nowadays, there's no button you push to compile it. It sort of gets compiled automatically while you're programming and at the point when you click run. Now, Java was novel when it was invented because traditionally, a C compiler is a traditional compiler. What a compiler did was take a program written in C, in this case, and translate it into machine code. So machine code is a language of ones and zeros that people just don't deal with. But it would translate it to machine code so that it could run on a computer. What Java does is it doesn't translate Java to, what the Java compiler does is it translates Java to a language called Java bytecode. Okay? So C compiler takes the program to machine code. Java compiler takes Java to bytecode. Two different languages, but it's a translation process. So that's all a compiler does, it translates. Then there's something known as an interpreter. So an interpreter is software or hardware that carries out the instructions of a program. So when you look at a program and you say you're trying to understand it or debug it, and you sort of run through it in your head and keep track on paper maybe the values of variables. You're being an interpreter. You're interpreting the program. You're running it. You're running it in your head. So you're playing the role of a Java interpreter. Now C, I said, the C compiler translates the program to machine code. So in that case, when you run the program, it's running directly on the computer. The computer is the interpreter. So there's a machine code language specific to each type of computer. And when you compile a C program on, say, on my computer to machine code, and it runs on the computer is interpreting the program. The computer is directly carrying out the instructions in the program. That's what computers were designed to do, for the last 70 years, 60, 70 years. Java's different. Java translates to a bytecode, and then to run the program, you have to have installed on your computer what's called a Java virtual machine. So that's one of the things you get when you install Java, is you get a Java virtual machine. And the virtual machine is a program that interprets Java bytecode. Now, the Java virtual machine is in turn running on the computer. But that's a different story. So there's multiple levels of interpretation going on there. So, can you see an advantage of the Java approach, which is becoming increasingly common these days, and the C approach? The advantage of virtual machine, yeah?
With the virtual machine, you don't have to compile on every machine you want to run the code on.
Okay, he said with the virtual machine approach, you don't have to compile for every machine you want to run on. So with the C program, if you run it on my computer, we compile it, we get an executable, we run it. And then it'll run on all computers that are like mine. But if we want it to run on a Mac, we have to compile it, compile it for the Mac. So you have different versions, different compiled versions for different machines. Whereas with Java, you just compile it once and it'll run anywhere. So that's a big advantage of that, is that you don't have to have specialized versions, different compilations for different kinds of computers. But what's the disadvantage? Yeah? You have to have a virtual machine installed. So, if you create, in Java, you can take your program and export it as an executable jar file, give it to someone, and they put it on their computer and double-click that jar file. The program will run as long as that computer has a Java virtual machine installed. If it doesn't, it won't work. Yeah?
Is there also any time or efficiency concerns with having multiple layers of interpretation?
Okay. So the question was, are there any time or efficiency concerns? And yes, there are. And in fact, that was one of the big criticisms of Java's approach 20 years ago, was that a C program, when you compile it, it's running directly on the hardware. Java program is being interpreted by the Java virtual machine, which is in turn running on the hardware. So you got this extra level of computation going on. So inevitably, a language like Java is going to be less efficient when run that way. Yeah?
If the Java virtual machine is what runs Java, what runs the virtual machine?
The virtual machine, so the question was, what runs a virtual machine? How does a virtual machine work? Well, when you installed Java, we downloaded JDK 10, you had to tell the website what kind of computer you're on, right? Where you had to download a version for Linux or for Windows or for the Mac. And that's because the Java virtual machine has to be compiled to machine code. And so you have to know you have to get the version appropriate for your machine. Okay? So that's stuff that we've just totally ignored. But as you learn multiple languages, it becomes important to know. I don't want your last thing you hear about Java being that it's less efficient than C, although it is. And it's good to know that almost at every advance in programming languages that's been designed to make it easier for people to program has been criticized because it makes the programs less efficient. And a long time ago, that was a huge deal because computers were incredibly expensive. And people were, by comparison, incredibly cheap. And so anything you did to make it easier for people to program, but less efficient for the program to run, was not a good trade-off. But nowadays, computers are essentially free compared to the cost of the programmers that program. And it's been trending that way forever. So it's only natural that languages are designed to be friendlier to people. Because that's where we are on the economic curve. Okay, first day of class, we talked about these high-level concepts. And at the time, they were kind of nebulous. Hopefully, they make a little bit more sense now. These four concepts: abstraction, taking a simpler view of a complex entity by selectively ignoring details. Tell me, where during this class have we dealt with abstraction? Where have you exploited abstraction? Where has abstraction made your life easier? Yeah?
Helper programs.
Okay, he said helper programs, helper methods. Okay, so sure, you got this piece of computation you want to have done, so you abstract it away. You say, let's create a method to do it, make sure the method works, then you forget about how the method works and just use it. So that's an example of abstraction. Yeah?
Commenting on code.
Okay. Adding comments, adding Javadoc to your methods is a form of abstraction, because when you have put Javadoc, the correct Javadoc on the method, then someone that uses your method just has to read the header of the method and the Javadoc. They can abstract away. They can ignore the details of how the method actually works. They just have to know what it does. Okay, I'll add one. All this stuff we abstracted away for the first half of the semester. Didn't have to worry about it. We selectively ignored all those details because we could do what we needed to do without knowing what a compiler was, or what machine language was, or what the Java virtual machine was. Where else have you used abstraction? Yeah?
In creating our own classes.
Okay, so we started creating our own classes. So we're taking, in classes, that's not covered in the midterm, but when you create classes, you're essentially saying, I need a new kind of thing, a new kind of object in my program. When you create it, you have to deal with the details, but once you've got it working, you don't have to know how it's implemented to use it. That goes for the entire Java the Java library. All those static methods and classes you've been using, you don't have the slightest hint of how a scanner works. Right? You don't know how strings are implemented. Random number generators, files, all that stuff. You abstract all those details away all the time. Imagine if you had to understand every single detail of every method and class that you used, all the way down to the quantum mechanics that govern how a computer works. You'd never get started. So abstraction is just totally key. Otherwise, we'd just be overwhelmed with details. It's what makes driving a car possible. I mean, I'm pretty sure that you hop in my car, if I gave you the keys to my car, you'd be able to get in it and drive it. Well, if you know how to drive any car, you can drive my car. Because of abstraction. What's the abstraction going on there? Yeah? Well, that would be a potential problem. My car happens to be an automatic, but yeah?
Like, you don't know how exactly the car functions, like how the starter turns on the rest of the car and how
Okay. Right, you can drive a car despite the fact that, you know, a lot of us have no idea really how a car works inside. You take an abstract view of the car, which is, you know, seat, steering wheel, mirror, ignition, and so forth. And all cars pretty much present the same abstraction to you. The big exception being manual versus automatic transmissions. What about decomposition? Dividing a large program into several simpler problems. Dividing a large problem into several simpler problems. Where have we seen decomposition? Yeah?
In your assignments, you usually give us some portions of that already done. So you work for us, we're given a chunk of task to do.
Okay. So, yeah, for a lot of these assignments, I've already decomposed it into pieces. And you know, I write some of the pieces, you write some of the pieces. And as long as you understand the decomposition, understand what each piece is supposed to do, and implement it faithfully, then you put it all together, it all works. And as we move into classes, that's another way you can decompose. You don't just create methods to help you create more complex methods. You create classes for the same purpose. And as you go on, in other classes, other courses, it becomes not so much the instructor's responsibility to do the decomposition, but your responsibility. So that's just a skill you have to learn, is how to take a big problem and decompose it into manageable pieces. That takes a while to master. Okay? An algorithm is an unambiguous step-by-step description of how to carry out a task. Now, there are entire courses, entire graduate courses, undergraduate courses, 2420, that deal with algorithms. Because there are lots of interesting ones that have been discovered over the years. But essentially, anytime you write a method, you are designing an algorithm to do it. say you want to add up all the numbers in an array. You've got to come up with a way to do that, and that's an algorithm. And finally, there's method. An abstraction of an algorithm with parameters and a behavioral specification. So that brings us back to abstraction again. A method is just, an algorithm is a description of how the computer is going to do it. Wrap it in a method, give it a Java doc. Now we don't have to worry. We can abstract away the implementation, abstract away the algorithm. We just need to know what the method does, not how it does it. So when you write a program, what we have found is that you decompose it into methods. You create a well-specified stub for each method. You create unit tests for each method. Then you implement the methods. And at that point, once you've got the methods debugged and passing your tests, you can begin to view them abstractly, like I've been saying. You no longer have to worry about how they're doing what they do. You just worry about what they do. And then you have building blocks to build the program. To specify a method, or at least to specify a static method, you describe its behavior in terms of its parameters, and that becomes a Java doc. Now, I've seen a lot of misunderstanding on this point. I see things in the Java doc when I look at student code that doesn't belong there. So the aforementioned method, let's say it takes an array of integers and it returns the sum of the numbers in the array. What would be the right Java doc comment for that? Yeah. Okay. I'll say it in slightly fewer words. Returns the sum of the elements in the array. Okay. Now, what kind of extraneous details can you imagine I've seen in Java docs for a method like that? I mean, we didn't do precisely that method. Yeah? Okay, how it works on the inside. So any mention of, if you mention the word loop in your Java doc, that's not right. So you wouldn't want a Java doc that said uses a for loop to add all the elements in the array, or uses a while loop, or uses a while loop to go backwards through the array, or anything like that. That's unnecessary detail. We want to boil it down to just what someone needs to know to use your method. They don't have to know that you used a loop, or what kind of loop that you used. Okay? Just what it does. Now the midterm kind of takes you way out of your comfort zone. There's not a lot of programming. You've seen the sample midterm. You know you're not writing big long stretches of code. But you are writing pieces of code. And you probably don't have, you may not have any experience whatsoever in programming on paper. And yet that's exactly what we're asking you to go to the midterm. So you could argue that maybe that's unfair. It's just the way it is. So I think it's a good idea to practice. Okay? So let's do that right now. If you got paper, fine. Don't use your laptops. I'm going to give you some code to write on paper, just so you can see that it's doable. If you need paper, let me know. I got paper. Okay. Sergio's got the paper now. So imagine this is a midterm question. Write a stub for a static method called isPrime that takes an int as its parameter and returns true if the number is prime or false otherwise. Okay? So just to be clear, stub means Java doc, the method header, and then a body with a return statement that just so the method will compile. Okay? So take a shot at that. I could very easily ask that on the midterm. I'll help you out. Start with /**. I want you to notice what it sounds like right now. That's what it'll sound like at the midterm. So the room will be different. There'll be, you know, someone will come with a cold though, so someone will be coughing the entire exam. And you may see the TAs laughing, you know, talking to each other and laughing. They're not laughing at you, they're just bored and just talking to each other like normal. Don't feel self-conscious. The TAs are for some reason laughing at you. Okay? So before we talk about a solution to this, what's the, you know, was it okay? Doable without Eclipse? What problems did you have? Yeah? Okay, he said what to capitalize and what not to. Well, and that's, you know, we are not nearly as strict as the Java compiler at grading your programs. So if you can't quite remember, was it parse int or int parse or whatever, you know, just get close. You'll be okay. If you leave out a semicolon or you forget a brace for some reason, as long as you're indenting so we can tell what you meant, you know, we're forgiving with that as well. Now there are some places where if I ask you, what is the name of this type, where capitalization is important. As you know, double with a lowercase d is a primitive, with an uppercase d is suddenly an object type. So there are some cases where capitalization makes a difference, but only in very small, precise places. Okay. So what's the answer? Let me get an Eclipse up here if I can show you the answer. Okay. Okay, so there's my answer. Public, static, Boolean. Okay, it's public because they just are. Although I didn't tell you whether to make it public or private, so that doesn't really matter. It's static. I said it was static. It's called is prime. It returns true or false, so you know it's got to return a Boolean. It takes int as a parameter. Is it a mistake to call it m or p or anything else? No. You can name it whatever you want. And to make it a stub, I just put a body in that returns false, just so it'll compile. And then the Java doc reports whether n is prime. Yeah?
If you were to click enter in your Java doc after prime and put like the and symbol or the at symbol, there would be the option to include like author, param, and other specifications. When do you use?
Okay. So if I wipe this out, you can see that it, and I start writing the Java doc, it gives me a place to describe the parameter in and to say what it is the method returns. You know, if you have the patience to fill all that out, that's good. I've just found that I just have a hard time writing the comment that describes what it does without describing everything anyway. I mean, I don't know what I could say about n here other than it's an int. Maybe I could say it has to be greater than 0. But I don't know what to say about returning. You know, it returns, I like to say for Booleans, reports whether p is prime. And then I'm stuck down here. What do I say about it returns? Whether p is prime?
Boolean.
Or whether n is prime. I could come down here and say returns
Boolean.
Well, I don't have to say it returns a Boolean. It says right there. I mean, what you're supposed to say is return.
They can't see that. They're looking at the Java doc.
No, when they look at the Java doc, they got the header as well.
If n is prime?
Yeah, thank you. I should have just called this p. That's what you got to call a parameter if the thing's prime. So yeah, tastes vary. I guess if I was doing something for a wide release, I'd be more careful about filling in all the blanks. But we're not going to take anything off on the midterm because you didn't. Yeah.
Can we find this midterm in the assignments to open up in Eclipse?
Okay, so yeah, this project is not there yet. I'll put it there at the end of class. There's really nothing to look at right now. Okay? So hopefully you did okay on that. Yeah?
I usually get confused, and maybe even when I see like at param and at return, sometimes I like get confused and skip them. So suppose I turned my is prime in, and all it said was divides p, takes the remainder of p divided by each number smaller than p to determine if p is prime, then it didn't say anything about those parameters like you just deleted.
Okay, so she asked several good questions. One is, I'll tell you the answer to it. I took out the at param that defines p, but is it true that my specification here ignores p? No, it mentions it, right? It reports whether p is prime. So it's referring to the p there. The other thing was she suggested a Java comment of the form tries to divide p by every integer less than p to see if they're in a remainder, basically describing how you would do this primality test. Okay, what do you think of that Java doc as compared to mine? Yeah?
The user programmer doesn't need to know that.
Right, too much detail. All they need to know is that it will tell you whether or not p is prime. The way it does it doesn't matter. Yeah?
So we're not supposed to like write how to actually do it, because yours will always return false.
Okay, so he's saying, are you not supposed to write how it actually do it? Because this always returns false. I asked you to write a stub. So this is a stub. A stub is just the header, the comment, and then a return. Sometimes the body can be empty. If the method's void, the body of the stub is empty. Otherwise, you need a return statement, or sometimes people use throws, just so the thing will compile. I wouldn't ask you to implement it. So that would be a tragedy on the midterm if you wasted 20 minutes implementing is prime, or 45 minutes it could be, and then you get that right, but miss everything else because you didn't have time to get to it. Yeah, be clear on what you're doing. And let me tell you some advice Stefan always gives. On these exams, I have learned to put boxes in which you write the answer. If your answer won't fit in the box, you're doing it wrong. Okay? Were there other questions? Yeah?
Just to recap, a stub is a Java doc, the header of the method, and a return statement.
A return statement, yeah. So what he was just reiterating what I said. A stub is the Java doc, the method header, and then a body. And the body can be empty if the method's void. Otherwise, you're going to have a return statement or a throw statement or something to make it. I use returns to make it compile. So a lot of times when I give you an assignment, I'm giving you stubs, right? I give you methods to implement. I give them to you in stub form, commented, and you have to provide implementation. Any other questions? Yeah?
If we named a variable like something we're not able to use in Java, like new or final, would that be correct?
Okay, so he's asking, suppose he decided to call this parameter new instead of p. Okay? Now, that happens to be a keyword in Java, and you know immediately if you're using Eclipse. And you ask, will we take off for that? No. We're just trying to see if you've got the idea. I could probably think of some, well, I'd have to think hard, but there are certainly keywords you haven't seen yet. Any other questions? Yeah?
So like my biggest fear writing stuff on paper is like not having the autocomplete to tell me like what methods there are for each thing. So would that be like a good thing to put on a sheet of paper as like different methods for different classes or for
Okay. All right. So his question was, he's saying that just like I do, he relies on the autocomplete in Eclipse to tell you what the methods are. So like you want to take the substring of a string. And I can never remember, is it substring or sub-str? Because it's one way in one language, another. So I hit dot, control space, whatever. It gives me the options. And I pick one. And he asked, is that a good thing to write on your cheat sheet? And I think it is. Commonly used methods, especially for strings, common things like strings, scanners, the classes that we tended to use. Jot down the common methods on your sheet. Anything else?
Well,
Yeah.
then I was just kind of plain confused by that, but by what you two were just talking about, because it sounds like what exactly would you be writing down about string or int?
Okay, so she's asking, what would you write down about these classes? I would write down, okay, there's the fact that there's a substring method that takes 2 ints as a parameter, just something to jog your memory. That it's called substring. That there's a method called equals. The kinds of stuff you depend on the IntelliSense and Eclipse to tell you. And again, if you spell substring wrong, we're not going to dock you points, as long as it looks sort of like substring. Yeah.
So if we can't remember that it's substring, and we're like, the string that is a part of this string, like that's the method, but we can't really remember what it's called. If we describe it, is that worth something?
Yeah. I mean, he's just basically asking, if you can't remember, it's called substring, but so you invent a name. But at this point, if any of you can't remember the name substring, I'll be disappointed. I've said it at least 10 times. Yeah?
On the midterm from last year, on number 8, it says like you can do this with a single line of code that does not involve an if statement. If you use an if statement, are you doing it wrong?
Okay, so he's saying that he had to provide, I asked you to provide a line of code, and the hint was you don't need to use an if statement. And the question was, if he uses an if statement, will we count it wrong? No, not unless it's stated as an absolute requirement. No. I put hints like that to make it easier for you, but also to make it easier for us. It's a lot easier to grade one line of code than several. Okay. I'm not particularly strict when I grade these things. If the TAs have their way, they'd be stricter. I find that the TAs are more stickler for perfection, but I'm more flexible. Okay, let's take a quick break and we'll continue along these lines. All right, let's get started again. All right, here's another exercise to do. Pretend you're taking the exam, and I ask you to complete the implementation of this method. So it's a method that takes in an integer n, and it's supposed to return a list containing all the prime numbers less than int. Okay? And you can assume that there's an isPrime method, like you just stubbed out. Another thing you'll see at the midterm is me and the TA sort of walking around like this, watching what's going on. I'm actually on my way out the door to get a drink of water. Okay, and another thing you might see at the midterm is I might go, I have a correction to make. And I have to say, I didn't mean to say string here. It's supposed to be integer. It's the rare exam I give that I don't make some mistake. I seem to always make one mistake. At least one. Another thing to know is you may, while you're taking the midterm, have a question. It's okay to ask. Sometimes we may tell you that we can't answer that question, but sometimes we do. And it's also how we discover those typos. So you can either come up and ask one of us in person or raise your hand. I think it works better if you just get out of your seat and come ask, because then we avoid disturbing the people that are sitting around. Okay, so while you can keep going if you'd like. How do you think this feels compared to doing it in Eclipse? Slower? I agree, yeah.
Oh, a question, do we have to draw ampersands? Would we have to do that?
Yeah. Well, okay, he asked, does he have to draw ampersand? So yeah, I mean, if you gotta do a conjunction, you know how, draw one in the air here. Like that? If that's beyond you, you're okay with that. Yeah?
What was that now?
Sounded like a good line, but I didn't quite hear it. Yeah, okay, so he's asking about curly brackets. And that's another,
Yep.
It looks roughly like that. Yeah? Okay, he's wanting me to draw an and before the midterm so that you can copy it if you need to. I'm not worried. You'll be able to get close enough to be safe.
Guys, what's so hard about an ampersand?
Put it in the notes.
Yeah.
Put it in your notes. Question? Nope. You hear that during the midterm.
Sorry.
Okay. So I got one comment that this is slower than using Eclipse. What makes it slower? Because you can certainly, probably most of you can type faster than you can write. Yeah? You can't immediately see when you make an error. Although really the errors that we care about on the midterm are errors in logic, kind of things that's not going to be called anyway until you at least run the program. That's another thing. You can't run it to see if you've got it right. Yeah?
You have to, by hand, do all the indentation and put it in brackets and stuff.
Okay, so you got to manage the indentation in the brackets yourself. Yeah?
You can't just add a line above, right?
Yeah, that is true. It's harder to edit when you got to go back and change it. So these are all reasons I try to keep the amount of code you have to write small. Yeah? I might give you a method and ask you what it does, for some code and ask you what happens.
Right.
So, yep.
Right, legible.
Write legibly. So we're using this new computer system to grade. So we're going to take all your exams and scan them and then grade them online. And one thing it does on these short answer questions, it reads your handwriting and it doesn't grade it, but it will put all the answers that look the same into one pile for us, one virtual pile, so that we can just give them all the same grade. Okay? So if you don't write neatly, it just makes grading harder. Yeah? Okay, the question was, does it matter if you write in pen or pencil? No, either one is okay. I used to say don't use red pen. I guess I'll still say that, because when we scan it, it'll probably be in color. Yeah, we grade with a red pen, so I'd rather you not use a red pen. Yeah?
Can we have no paper so we can write it down in pencil and then write it on the test pen so it's more legible for the computer? That way we don't have to can't waste pen.
If you want to use blank paper, scrap paper, that's okay. But I want you to, whatever paper you use, hand it in at the end of the test. Your notes or your scrap paper. Yeah?
In case the fancy grading system doesn't work out so well, is there like a regrade process? Or
Well,
like something got graded incorrectly?
Okay, so the question is about regrading, and I'll have lots to say about regrading, but after the midterm. They're not being graded by the computers. This is just computer assisted. Just help us manage. Rather than having 350 exams we got to pass around and, you know, and lose track of and so forth. It's just online now, so we can't lose any. Yeah.
So do you want all the answers that are like most correct to be similar? Do you want us to keep the format of the curly braces being after the headers, or do you want it to be?
Okay, so he's asking about the format. Yeah, I prefer that you use the same formatting I've been using. But I won't count it wrong if you don't. Okay, so hopefully you've gotten a little experience with programming on paper. Let's look at the answer to this one. Well, I don't have an answer to this one. What is the answer to this one? What kind of loop is called for here?
Accumulation.
Right, this is an accumulation loop, so I need to have an accumulation variable, which is going to be an array list of strings.
Integers.
Made the same mistake here. An array list of integers. I'll just copy that. All right, so I create an empty array list of integers. I gotta call it something. Call it primes. All right. So that's my accumulation variable. When I'm all done, I'm going to return primes. And now I've got to consume, I've got to write a loop. Let me do it this way. No, it's got to be at least 2 to be a prime. So that's just the enumeration loop for an interval of integers. And right here, I've got to put something to actually do the accumulation. So what is that? Right, we got to test P to see if it's prime. And if it is, just add it to the list. Okay, so that's a classic accumulation loop. Yeah?
Wouldn't a for loop technically be better there?
The for loop would work, yeah. Yeah?
Sometimes, like, if you don't know, like,
Okay, you're asking if a method doesn't exist, it's your best chance to write it.
I mean, like, if you don't know if it's like, I didn't know this was an prime method.
Well, yeah, well, I mean, I say there's an is prime method. I wouldn't waste time. Yeah, I don't think you want to be trying to implement helper methods unless I ask you to. Not that writing helper methods is a waste of time, but it goes back to that advice. If it doesn't fit in the box, it's probably wrong. If it's a 2-point question and you think you're going to have to write a 1-page long method, you're probably wrong here too. Okay. Yeah?
Is there a way to check if it's a prime number without the usage of the prime method?
Without the use of what?
Without the usage of the prime method, is there another way to check if the number is a prime number? Because I didn't know that it was a prime method.
Okay, he's asking, is there another way to test for primality in the Java library? I mean, in the big integer class, there's an is probably prime method that'll tell you if a number is probably prime. It turns out that deterministically testing if a number is prime is very inefficient. But that's a story for another day. Take 4150 and I'll tell you all about that. Okay, so I've got some more slides here that just are places maybe that will cause you to ask a question. So we got 15 minutes left. So we're just going to drill down on stuff you've learned about Java. So you know that a program is made up of one or more classes organized into packages. And the package is just a folder full of source files. Yeah?
So are all the questions going to be like writing stuff, or is it like multiple choice?
Okay, so the question is, are all the questions going to be coding stuff, or are there other kinds like multiple choice? Yeah, the minority of the questions will involve coding. Well, I can't say that. There's a good balance between coding and non-coding questions. Look at the sample midterm and the next midterm. Your midterm will be similar to that. Yeah?
Will we need to worry about importing at all?
That's a good question. You ask about importing, because normally when you write a static method, it's in a class that's in a package that has imports at the top. And I'm just asking you to write the code for the method. You don't need to worry about writing the imports. Just assume that what needs to be imported has been. Okay? So we also know that a class can provide static methods. Okay? It can contain other things, but for purposes of midterms, classes exist to provide static methods and also static constants, I guess. Static method provides a new operation with name, parameters, a return type. It may terminate by returning something or throwing an exception. And then internally, a method is a sequence of statements. So this is stuff we did the first week. Talked about static methods, or maybe the second week. And we spent most of the rest of the time figuring out what could go in the body of the static method. And what can go is statements. So between the brace that begins and the brace that ends a static method, you have a sequence of statements. Statements are made up of simpler statements and also expressions. So we learned about local variable declarations. That's a kind of statement. Another kind is an expression that has a side effect, like system.out.println. There are assignments, conditionals, different forms of loops, return and throw statements, try and catch blocks, break and continue. So those are all kinds of statements that we looked at. So yeah, you need to be familiar with these statements and know what they do, what they mean, what happens when they're executed. And you got a question in the back, yeah?
What's the difference between like a if and then throw new exception versus a try catch block?
Okay, so the question is about the relation between throwing and catching, I guess. Okay? So if you want your exception to terminate right now by throwing an exception, use a throw statement. You say throw illegal argument exception or throw array index out of bounds exception. And that causes your method to end by throwing an exception. Try catch blocks are not for throwing exceptions, they're for catching them. So if you want to know if one of the methods that you're calling terminated by throwing an exception, you need to put that method call in a try catch block, and then you can catch the exception. Now, I get this question even in 3500. I'll say, write a method that does thus and such, and if the parameter is negative, throw an exception. And I'll have students that will throw the exception and catch it all at the same time inside the method, so the method doesn't actually terminate. Okay? When I say method throws an exception, that's something that has to be externally observable. I have to, if I call the method, I want to see it terminate by throwing an exception. It doesn't mean throw and catch the exception. And students will argue all the time. They say, well, I threw an exception right here like you asked. But that's not what I have in mind. Yeah?
You might have like a try catch in the main method, or as in the other ones, like a couple methods you have.
Yeah. I mean, very often in a serious system, you'll have a try catch around the main method. So
Repeat the question.
If there are any programming errors.
Can you repeat the question?
Oh, he was proposing a use for a try catch in the main method. So wrap your main method, and so that if there are any problems with your program that result in exceptions, you catch them and log them somewhere so you can know a problem happened And then you display something to the user that says, you know, oops, something went wrong, please try again. And I bet you've all seen that in an app or a program or something where it pops up a window that says, temporary problem, please try again. And that's probably an exception being masked. Any other questions about these statements? Yeah?
Catch block has to follow the try block, right? You can just have a catch block.
Right, okay, so he's asking about, can you have a catch without a try? No, it has to be try, catch. Yeah?
Should we be concerned with finally blocks for this?
Okay, he's asking about finally blocks. I haven't made a very big deal, so no, you don't need to be concerned with them for the midterm. Yeah? Okay. Who knows what, he's asking about the continue statement. What does it do? Yeah?
Jumps back to the start of the loop.
Okay, so it basically, it can only appear inside a loop, and when you say continue, it just skips the rest of the current repetition and goes on to the next one. Also break. Okay, what does break do when it shows up in a loop? Terminates the loop. Forcibly terminates it, and then you just go on with whatever follows the loop. In the old days, programming languages had go-to statements. And so you could just say go to X, and then no matter where you were, it would transfer, it would start executing the statement labeled with an X. And so continue and break and even throw and catch are sort of what remains of the old go-to, sort of structured forms of what used to be done with go-to statements, because unrestrained use of go-to statements created what was called spaghetti code, where you look at it and it runs and it skips here and then it runs here and it jumps back over here. It's just hard to figure out. Yeah?
So if we use scanners on the midterm, do you want us to define it inside of try that it closes by itself?
Okay, so you know that he's asking about defining scanners with try with resources. So that's another use of the try block that doesn't require a catch, where you open things that can be closed. No, you don't need to worry about closing the scanners if you happen to create one on the midterm. Any other questions about statements? Yeah?
Can you give some examples of expressions and side effects?
Okay, so the reason I say expression with a side effect is if you try to put a statement, if you try to put an expression, use an expression as a statement. So let me go back to the clips here. So suppose right here I say 2 plus 2. That's an expression I'm trying to use as a statement. And basically Java's telling me, well, giving me a stupid message, but basically 2 plus 2 is a useless thing to use as a statement because you execute it and so what? You've computed 4 and then you throw it away. The only time it makes sense to put an expression right there is if it has some sort of side effect. Okay? It does something visible to the user. Like, let's say you make a method called to bring up a dialog box. The fact that the dialog box appears is the side effect. So it makes sense to call a method that brings up a dialog box and do nothing with the return result. Or you do system.out.println. The side effect is something gets printed. Anything else? Okay. Now statements are composed of expressions. And there are lots of different kinds of expressions. I probably forgot some here. There are literals like to and true and 3.14. There are variables that can either be the parameters that show up in the header, those are called formal parameters, or local variables you declared, or static constants. Yeah?
One moment.
All right, while you're doing that, I'll go on.
Well, now I'm ready to.
Now you're ready, okay.
Okay, so we'll back to the statements. I know that like return and throw / try and catch are both used for catching errors. So can they be used together somehow, or do they ever get
Okay.
used?
So she's asking about return and throw and try and catch. I mean, return is for ending a method and saying what the return value is. But often throws and tries and catches are used together. One method will throw, the other method will catch.
Then, so it can be either a throw catch or a try catch?
No, there's no such thing as throw catch. There's try catch. There are try blocks and there are throws, throw statements. They're two separate things.
Okay. But it seems it's intuitive that if you threw something, it would be caught. And
Okay, so she said it seems like if you threw something, it would be caught. And if you throw something, it must be caught. Otherwise, what happens? Program crashes. If the thrown exception makes it all the way out of main, then the program ends. Okay, so these are kinds of expressions we've looked at. Literals, variables, operators, 2 plus 2, method calls, new expressions, you would create new objects, array expressions. I guess I didn't put on here calling a method on an object with the dot notation. Object dot method, s dot substring. We made a big deal earlier this semester on types, variables, and values. And I'll just tell you, the first couple questions on the midterm will be just like the first couple questions on the sample midterm. You'll be asked to figure out the type and the value of different expressions. So be sure that you're tight with all that. You need to be familiar, this is a good thing for the cheat sheet, with I'm not going to have you write any graphics code. That would be particularly cruel on a paper exam. But you need to be familiar with the basic methods for these classes, like I've said, going along. Okay, got 3 minutes left. We've already talked about that. And test-driven programming. That's on here for completeness. The idea that what you spend a lot of time, you spent time learning how to write tests, right? How to write JUnit tests. And that's part of the idea that you create a static method stub and then create some tests for it. And then you've got test cases that you can use when you're implementing. Yeah? On the exam, this is why, I'm not going to have you do this full cycle on an exam. Yeah. That's just too much. Be familiar with arrays, how to declare them and create them, how to access, modify them, and get their size. Be familiar with the stuff from PS6, lists, sets, and maps. Okay? Look, I just posted the solution to PS6, so you need to be reasonably good at building things, looking up things in maps, iterating through lists, iterating through sets, that sort of thing. And then the rest of these slides, I'll let you look at on your own. They describe the different forms of loops that we talked about. And that's critical as well. So anyway, I'll end here. You have more chances tomorrow in lab and also tomorrow at 5:15 to ask other questions.